Okay, good morning dear students. Today we will learn relative extrema. This topic also known as first derivative test uh, of a function. Basically, before starting this topic, we should know about critical point. दोस्तों, critical point. This is very important role to understand the first derivative test. This is a critical point. Basically, the critical point is a point at which the first derivative of the function equal to 0. The point is known as critical point. Graphically, suppose that we have a function like this. The point at which the first derivative of the function is 0 is known as critical point. For example, suppose at this point, if you want to find the tangent of the function at the point A, suppose that this point is A, then we can put tangent at the point A is parallel to the x-axis, and this is the x-axis, and we can see that the first derivative of the function equal to 0. It means this point is a critical point. Similarly, this is a critical point, this is another critical point, this is a critical point, but we can't put tangent at this point. There is no existence of the tangent because we can put infinite number of tangent at this point, but this is a critical point because सारे इनफाइनाइट टेंजेंट्स में से कम एक टेंजेंट तो ऐसा होना चाहिए जो कि एक्स एक्सिस के पैरेलल हो. ओके, सो द पॉइंट एट विच द फंक्शन चेंज मैक्सिमम टू मिनिमम फंक्शन change its slope from positive to negative or negative to positive, that point is also known as critical point. We can also say that a point at which the function change its slope from positive to negative or negative to positive, and that point is also known as critical point. For example, at that point, first the slope is positive. This is the positive slope. Then slope is negative. Here is slope negative. This slope is positive. This slope is positive. This is negative. This is negative slope. This is positive. This is positive slope and negative slope. It's mean we have the critical points are 1, 2, 3, 4, 5 and so on. Okay. So critical point is the point at which the first derivative of the function is equal to 0 or the function change its slope from positive to negative or negative to positive. Okay, student, this is the critical point. Now, the second is relative extrema. First, the relative extrema is a point. This is a graph. Suppose that this is a graph and this point is A, this point is B, or we can say this point is x0, this point is x5. Okay, and at x0 we have the graph, the point of the graph at x0 is, suppose that y0, y dash. Suppose that point is y. No, suppose that point is A in y-axis. It means the coordinate of this point is x0 and A. Similarly, the coordinate of this point is x5 and 0, x5 and 0, or we can say that x5. Okay. Now, if we want to find the absolute maxima and local maxima, absolute minima and local minima for this type function, then the highest point, the highest maximum value of this function, this is the highest maximum point, this is the highest maximum point, is known as absolute maxima. This is the absolute maxima, absolute maxima. Okay, this is the absolute minima, okay, and between the absolute maxima and absolute minima, the other maximum and minimum points are known as local maxima and local minima. Okay, for example, suppose that we take this point. This is, suppose that this point is x3. Okay, this is the point x2. This is the point x4, and this is the point x4 dash. For example, for this point, this is also a maximum point, but this is a local maximum point, because this is a local maximum point because we have absolute maximum and absolute minimum, right? इन दोनों के बीच में एब्सोल्यूट मैक्सिमा और एब्सोल्यूट मिनिमा के बीच में लोकल मैक्सिमा भी होगा, लोकल मिनिमा भी होगा. अगर मैं इस पॉइंट को देखूं, सपोज दैट दिस पॉइंट इज C. ओके, देन द कोऑर्डिनेट ऑफ दिस पॉइंट इज x3 एंड C. अब मैं इस पॉइंट को देखूं, at x3 suppose that this function is fx. At x3, fx3 is, if fx3 is greater than equal to fx for every x belongs to the neighborhood of x3, it means x3 minus h, x3 plus h. Okay, only for the neighborhood of x3, if this condition satisfy, only for the neighborhood of x3, if this condition is satisfied, then this is the local maxima. Okay, for example, this is the, when we approach, for example, when we approach, अगर आप यहां से अप्रोच करेंगे इस पॉइंट की तरफ, x3 की तरफ, then you have a positive slope and then you have negative slope. In the neighborhood of x3, at that point, the value of fx is less than, and in the neighborhood of x3, right hand side, the value of fx is negative. It means this x3, the value of the fx at x3 is greater than equal to fx for every value in the neighborhood of x3. आप x3 के neighborhood में जितने भी पॉइंट है उन सब के लिए चेक करके देख सकते हो कि fx3 ग्रेटर देन होगा fx के लिए. इट्स मीन दिस पॉइंट इज लोकल मैक्सिमा. This is the local maxima. Okay, similarly, for finding the local minimum, suppose that this point is local minimum. Okay, this point is local minimum and this point is x4. It means the value of the function fx4 is less than equal to fx for every x4 belongs to x4 minus h and x4 plus h. इसके नेबरहुड में जितने भी पॉइंट है उनके लिए x4 फंक्शन की वैल्यू x4 पर fx की सारी वैल्यू के लिए क्या होगी, लेस देन होगी इसके नेबरहुड में. इट्स मीन ये वाला पॉइंट क्या होगा, लोकल मिनिमा. दिस पॉइंट इज लोकल मिनिमा. Okay, this is the concept of the local minima. So the highest maximum point is absolute maxima, the lowest maximum point is absolute minima. The other point between the absolute maxima and absolute minima are the local maxima and minima. The property of the local maxima is this, the property of the local minima is this. Now, what is the relative extrema? Okay, now the question is, what is the relative extrema in this graph? Relative extrema is a point, suppose that this is the relative extremum point, a point at which function change its slope. Okay, that point is known as relative extremum point. It means in this point the function change its slope from positive to negative. This is the positive slope f dash, f dash x greater than 0. This is the negative slope. F dash x less than 0. Okay. One is the positive slope, other is negative slope. It's me. This point is the relative extrema. Positive slope to negative slope. This point is relative extrema. And how can we say that this point is a maximum point? A point is maximum point if a point is a maximum point if function change its slope from positive to negative. If function change fx change its slope from positive to negative. It's mean function change its slope from positive to negative. Okay, when we approach to x3, then the slope is positive, and when we cross x3, then slope is negative. When we approach to x3, then slope is positive. When we cross x3, then slope is negative. It's mean this point is maximum point. This point is maximum point, local maximum point or maximum point. Okay, this is a relative extremum point in which the function change its slope from positive to negative, and this point is maximum point. Similarly, the minimum point is, for example, this is the minimum point. The minimum point is a point in which the function change its slope from negative to positive. If fx change its slope from negative to positive, okay, from negative to positive, then the function is known as then the point is known as extreme. Then the point is known as local minima or minimum point, or the point also known as relative extremum. It's mean the point at the point x4, the function change its slope from negative to positive. Okay, student, this type condition of a function, this type condition of the slope, when the slope change from negative to positive and positive to negative, and the study of this type slope of the function, and the study of the behavior of the function, and the study of the maxima and minima point of the function is known as relative extrema. Okay, student, this is all about the relative extrema and the first derivative test of the function. Thank you.